Hi, my name is Kazdaridis and I will present you our work with the title eProfiler, a high-precision power monitoring system for IoT devices that feature extreme dynamic range of operation. In this paper, we developed a dynamic shunt resistor switch formed by 3 resistors that are enabled depending on the flowing current. Specifically, we bypass the 2 resistors when required using 2 load switches. For example, when monitoring milliamp currents, the 2 resistors are bypassed. When measuring microamp currents, the first switch is open, so the current flows also across the second resistor. Finally, when monitoring nanoamps, both switches are open. The overall architecture we followed is presented in this figure. A dynamic shunt resistor switch that supports 3 different ranges is implemented featuring a 1 ohm, a 100 ohm, and a 10k ohm resistors. The embedded PC we opted for is the Linux-based BeagleBone board, which is a low-cost embedded platform characterized by sufficient processing power capabilities, low power consumption, and several communication interfaces. The ADC we employ is the Texas Instruments ADS8332. The ADC features 16 bits of resolution, high SNR, high PSRR, and performs conversions at 500 kilosamps per second. The selected ADC integrates a multiplexer circuit, thus supporting parallel sampling of up to 8 inputs, while the overall sampling rate is divided to the employed channels. So, for example, when monitoring 3 inputs, the maximum retained speed is 160 kilosamps per second. The current amplifier we selected is the MAX 9923. The MAX presents excellent characteristics in all parameters, while its crucial benefit is its ultra-low input bias current, which is 1 picoampere. The alternation of the resistors is realized through the high-speed comparators without the intervention of a logic unit that usually induces significant delays. In order to measure power, leveraging all 3 bands of eProfiler, we employ the EZ430. The EZ430 is configured to operate for a few seconds in active state, draining a few milliamps. After that, for a few seconds in low power mode 0, consuming few nanoamps, and then switches to the low power mode 2, where it drains several hundred microamps. Apparently, this experiment utilizes all 3 bands of the eProfiler. A close look to the video illustrates that the band LEDs follow the consumption behavior of the EZ430. The acquired data validate the correct operation of the eProfiler in the different ranges. Thanks for your attention. Please feel free to ask any question.